All right, we're going to talk about determinants and Cramer's rule. First thing I want to talk about first is what happens when I multiply these two. Let's kind of go through this real quick. I may just pause it and fast forward actually, just for the sake of time. But let's multiply these two matrices. So as I do that, this is what you get. 5 and 4, 3, and 1. Did you see what the answer turned out to be? The answer turned out to be this first one right here. This actually is like a 1. This is actually 1. And the way this works is, if you had, I'm just making this up, a 3 by 3, GHI, if you had a 3 by 3, you can make your 1, so to speak, by 1, 0, 0, 0, 1, 0, 0, 0, 1. You see how the diagonals all have that 1 in the first place, and then the second place, and the third place, and everything else is zeros? If you multiply this first one by this, almost like an identity a matrix, it'll give you back what you started. So that's what 1 does. When you multiply by 1, you get back the original. I just wanted to show you that you can actually make them as long as it starts off like this. And 4 by 4, it would be 1, 0, 0, 0, and then 0, 1, 0, 0, and 0, 0. It'll keep going as long as the 1s are kind of like in diagonal and everything else is zeros. And you can see it, the proof of it, based on this one. I just wanted to start off these notes with that. So now let's get into the determinant. The determinant, and this is something that I want you to get in your notes, this whole thing right here, so you may need to pause it. We are basically, and this is steps, this is important, this is anything above a 3 by 3 and above, and a 2 by 2 is simply right here. We're going to show you, or I'm going to show you examples on how to work this, alright? But this is what's called the determinant. We're going to use this several times. Notice you're adding some things and you're subtracting some things. But just get this down, and I'm going to explain the process over, okay? You're talking about diagonals here, all right? So pause this and get that down. Now, okay, this is a 2 by 2 matrix. And the way this works is you take the diagonals and you multiply them. There's only one diagonal in that direction. So 5 times 1, and then I'm going to subtract that from the other direction diagonal, which is 3 times 4. So really this is 5 minus 12, remember order of operations, and that equals -7. That's the determinant here, is -7. 2 by 2s are simple. Now a 3 by 3 is a little bit different, because what we have to do is extend this a little bit in order to get the new, to be able to do all the diagonals. So here's the step. If you got a 3 by 3 or anything like this, you got to rewrite the first 2 columns, 2, 4, 3, -1, 1, -4. That's what it was saying in that key concept that you wrote down. You need to make sure that you write down those 2 columns. Why is that important? Because now, look what happens. You have, let's see, this, this, and this, and you have this, this, and this as your diagonals. So 2, 1, -2, -1, 0, 3. Notice how I marked through them, because those are what I'm going to multiply. So I'm going to take all the ones in the red ink and multiply those. Alright? So 2 times 1 times negative 2, that is negative 4. All right, and I'm going to add that to negative 1 times 0 times 3 is 0. And I'm going to add that to negative 3 times 4 is negative 12. Negative 12 times negative 4 is positive 48. So what did I do here? First, I rewrote these two columns over to the right. That's the process whenever you have to find the determinant. Okay, so that's what I'm doing here. I am finding the determinant. So in the 3 by 3, I took the first two columns and I wrote them over here. Then I drew my diagonals so I can see that I have actually 3 diagonals here. And then in the opposite direction, you're going to have diagonals in each direction. So all these together are going to be subtracted by all these here written in the pencil here with the line drawn through it in the pencil. So 3 times negative 3 is negative 9. Negative 4 times 0 times 2 is 0. Notice I'm adding all these inside the parenthesis and I'm going to subtract that. Negative 2 times 4 times negative 1 is 8. So I add all those up together. Alright, so now this becomes 44 and this is negative 9 plus 0 plus 8 is negative 1. So really this becomes 44 plus 1, which equals 45. That's the determinant. Alright? Alright, let's do another determinant. Alright? I'm finding the determinant in this 3 by 3. Step number 1 is rewrite the first two columns. Now I'm going to mark I didn't mean to use the black pen, diagonals that I'm going to multiply. Now I'm noticing it makes sense to kind of make sure that whenever you do this that you write everything in a kind of decent consistent space, because you might tend to mark the wrong thing and draw an angle through the wrong numbers here. So be careful of that. I'm noticing that here as I the two and those are not all together lined up. Kind of makes it a little bit difficult. It's not that bad, but just be careful. You don't want to pick the wrong number. Alright, real quick. Negative 4 times negative 4 times negative 2 times 8. 1, if I can just talk right. That's negative 8 plus negative 1 times 0 plus 2 times negative 3 times 5. So that's negative 6 times 5, which is negative 30. And that's minus what's in the red, the other diagonals. 0 times anything is 0. This will be negative 20. Why? 5 times negative 1, and then negative 5 times 4. Plus 1 times negative 3 times negative 3. Negative 1 is 3. So, that's those. Now, this is negative 38 minus 20, which is negative 58. Alright, so if you caught that, then good for you. This is actually incorrect right here. That is actually minus a negative 17. This right here becomes negative 17. I skipped right over that 3, forgot it was in there. Negative 20 plus 3 is negative 17. And when you do minus a negative 17, that actually becomes negative 38 plus 17, which is negative 21, which is the correct answer. Oops, I made a mistake, but I caught it, so it doesn't count. Okay, this is Cramer's rule. This is something you want to get down at the top up here, really, this is dealing with systems of equations and determinants. This is kind of getting into why we went into matrices or matrix right after we were doing systems of equations with 2 variables and 3 variables and stuff, because you can actually use this to actually find the answer. And so here's how you would do it in a 2x2 system. First of all, if you have 2 equations written like this, then you can actually take the coefficients on this side, and that's called the coefficient matrix. Not E and F, not what it equals, but the A, B, and the C, D, the 2 coefficients on this side, and make a coefficient matrix. Now, Cramer's rule says that you're actually, once you find the determinant, you can actually, well, let me rephrase that. The determinant of the coefficient matrix is important, and I'll show you this in an example. You will divide the new matrix. Now, you guys say, what new matrices? These right here are important to remember. If this is the pattern, look at E and B and F and D, okay? And E and A and F and C, or, you know. Anyway, look at the order. This is important, so write this down, and I'll show you this in a second. It says, notice that the numerators for X and Y are determinants of the matrices formed by replacing the coefficients of X and Y respectively with the column constants, okay? With those. The constants are those right there. So replacing the X's and Y's with the constants. And I'll show you this here in a second. Okay, so now we're going to use Cramer's rule to solve this system. Normally, we would do substitution or elimination or graphing even and find out the solution. But what I want to do is actually use Cramer's rule. And there's the stinking bell. So for the sake of time, what I'm going to do is write out some of the things. The first thing I'm going to do is the coefficient matrix, which is 9, 4, 3, -5. And I have to find the determinant of that. So here is my determinant. So now what I have to do is I have to apply Cramer's rule because the determinant is not 0. So let me set that up and I'll show you how to work that. So what I'm doing now is this part right here. I found the determinant of A. That's the -57 that I'm going to use, that you're going to see here in a second. Now I'm using this pattern. This pattern says E, B, like the constant, and the B, the number with the Y, and F, and the number with the Y in the other equation. That's the X coordinate. And the Y coordinate is E, A, well actually AE if we're going left or right, AE and CF. So I'm taking these numbers and look at the order that they're in and where they're going to end up here. Both of them over the determinant of A. So look at what I did here. I wrote this out, that and that horizontal, that and that horizontal, that and that horizontal over the determinant 57. And the same thing, 9 and -6 and 3 and -21 here. And so what I'm going to do is the discriminant of the numerators and divide them both by the denominator, which is -57. Well, here's the real deal. I went ahead and did it. Cross multiply and cross multiply. You get those and you got to subtract them over the coefficient matrix here, the determinant here, over -57. When you add those together, you get 2. Same thing. Those 2 times each other, those 2 times each other. You have to subtract, but subtracting a negative becomes a plus, and when you divide those, you get a 3. So what actually happens is I didn't have to do substitution. I didn't have to do elimination. I actually was able to find out where these 2 lines intersect using Cramer's rule, which is using matrix multiplication and determinants. Now you may have to pause this because it's going to cut off, but this is what you would do for a 3x3 system. Alright, and so we've talked about these, and this is kind of where we want to get up to. Copy this down. See you in class.